So in this video, we'll be discussing two methods for the synthesis of magnetic nanoparticle. The first one being the co-precipitation method and the second one being the polyol method. First, let's discuss about co-precipitation method. So the co-precipitation method is the most widely used and the most popular method for the synthesis of magnetic nanoparticles. Why is that? Because it is very easy to perform. And the second reason being it's a green synthesis process. What do I mean by green synthesis process? It means that we require very less harmful materials and procedures to perform this experiment. So it is widely preferred by industries because it's a green synthesis process. Now, the photo that you see on your screen right now here, this is the photo of nanoparticles that we obtained after performing this method. So, how do we perform this? What is the principle behind this method? What we are doing is we are taking two soluble aqueous salt and bases, two soluble aqueous salts and a base. Okay, so what do I mean by two aqueous salt? For example, let's take an example of Fe plus 2 plus Fe plus 3. Let's say we have to make a magnetic nanoparticle Fe3O4. The nanoparticle Fe3O4 has magnetic properties and it's an oxide of iron. So we need to make this. How will we make Fe3O4 using this method? Let's see. So what we'll do is we'll take source of Fe plus 2 and Fe plus 3. Let's say we'll take FeCl2 as a source of Fe plus 2 and FeCl3 as a source of Fe plus 3. Now what we'll do is we'll make an aqueous solution of FeCl2 and FeCl3 as so that we can get Fe plus 2 and Fe plus 3. Now we'll add them together in a beaker. We'll add them together in a beaker. Okay. Now what we'll do is we'll dropwise add a base. In this case, the base that we use is NH3OH. Base will add dropwise. What we'll see is, and we'll also one more thing, we'll place a pH sensor here to monitor the pH. So now what we'll do is we'll dropwise add the NH3OH. After some time, what you'll notice is that the color is changing to black and the pH is also increasing. So pH we can vary depending on the type of nanoparticle, the morphology of nanoparticle that we want. So it can be varied from 8 to 14. In this example, let's take the pH to be 10. So when the pH goes above 8, you'll see that the color is starting to change to black. And when it comes to pH 10, we'll stop the NH3OH. Now what we'll do is we'll place this beaker into a microwave oven or whatever and heat it for 2 hours, around 2 hours at 80 degrees Celsius or 60 degrees Celsius depending on the morphology of nanoparticles that we want. Temperature can be varied, pH also can be varied. The ionic concentration of FeCl2, Fe plus 2 and Fe plus 3 can also be varied depending on the type of nanoparticle that we want. So this is how, after heating we'll get a black PPT. That black PPT is nothing but the nanoparticles of Fe3O4. So let's read the slides. Two soluble aqueous salts plus a base, as I told. Inert atmosphere is required for this method. So what do I mean by inert atmosphere? So basically it's an atmosphere in which oxidation cannot occur. For example, we are taking two salts here, Fe plus 2 and Fe plus 3. If the atmosphere is not inert, this will get oxidized into FeO, FeO, Fe2O3. Anything can happen. So our desired product is Fe3O4, but we'll not get that because these Fe plus 2 and Fe plus 3 will get oxidized and form another product. We do not want it. That is why inert atmosphere is required. So no use of surfactant and co-surfactant. Yeah, this method is preferred because we don't need to use any surfactant or co-surfactant in this method. And filtration using high temperature, as I told, we keep it in a beaker and we keep it heated for around 2 hours at 60 to 80 degrees Celsius, depending on the morphology of the nanoparticles that we want. So now, how do we check that the nanoparticle solution that we have made has magnetic properties or not? So let's look at a video in which we'll see if the solution has magnetic properties or not. As you can see in this video, the solution of Fe3O4 will move with the magnets, as you can see. So this clearly shows that these particles have magnetic properties. Now, what are the advantages of this method? So the most important advantage of this method is that the morphology of the nanoparticles can be controlled by using this method. How can we control the morphology of these nanoparticles? First of all, types of salt used. We can vary the type of salt used. Like we can use other salts such as chlorides, sulfates. We used FeCl2 and FeCl3 in the particular example that we took. But we can also take Fe3SO4 or anything like nitrates, perchlorates, sulfates, anything can be taken. So the type of salt used can be varied, and depending on the salt, we'll get different morphology of the nanoparticles. The ionic ratio can also be varied. So in the example that we took, that I took from a research paper. In that research paper, the preferred ionic ratio of Fe plus 3 to Fe plus 2 was 2 is to 1. But this ionic ratio can be varied to obtain different morphology of the nanoparticles. pH value, as I told in our example, we took the pH value of optimum pH value of 10. But the pH value can be varied from 8 to 14, and depending on the pH value, the morphology of the nanoparticles can be controlled. And reaction temperature. The temperature of the reaction can also be varied. It can be varied from 60 degrees Celsius to 80 degrees Celsius, and depending on the temperature also the morphology can be changed. So using these methods, around 2 nanometers to 50 nanometers nanoparticles can be obtained, and this is a very easy method, but there are some disadvantages. So let's look at some of these disadvantages. So what are these disadvantages? As we are not using, as I told, we are not using any surfactant or co-surfactant in this method. So there is a tendency of these particles to agglomerate because we are not using any surfactant or co-surfactant. Now the second disadvantage is maintenance of a particular pH. We need to maintain a particular pH. Like in the example we took, we had to maintain a pH of 10. Even while heating the solution, we had to maintain that particular pH. So it's a tedious process to maintain that pH. So it's a disadvantage. Another one is inert conditions required. Obviously, if we have to perform this method, we need inert conditions. Inert conditions is again non-oxidizing environment. So for that we have to use special type of beakers with 4 inlets, 3 inlets, and we usually do it in nitrogen atmosphere. So inert condition is required, and that is also a disadvantage. The fourth one is hydrolysis of nanoparticles might occur. As I told, we are using aqueous aqueous salts here. We are using the aqueous salt. So aqueous salt is basically in water. So hydrolysis of fine particles might occur in this method. So that is again one of the disadvantages. And the last one is not feasible at very high temperature. What do I mean by not feasible at very high temperature? So as these are aqueous solutions, we cannot use temperatures more than 100 degrees Celsius because the water will evaporate at 100 degrees Celsius. So we can use it till like 90 degrees, 95 degrees, but not at 100 degrees or above. So this is again a disadvantage. Now the polyol method that we'll discuss next will majorly overcome all the disadvantages this method has. So now let's discuss the polyol method. So the photo you see right here, this is the photo of nanoparticles that we obtained after performing polyol method. It's a very simple technique and it is very much same to the co-precipitation, but it will basically overcome all the disadvantages of co-precipitation method. How? Let's see. So first let us discuss about polyol method. So the only major difference between polyol method and co-precipitation method is that in co-precipitation we are using aqueous solution, but in polyol method we are using non-aqueous solutions. Okay, now the in this method inert atmospheric conditions are not required. Why they are not required, we'll discuss later in the coming slides. In this method also we don't need to use surfactant or co-surfactant, and in this method also filtration is done using very high temperature. So what are the advantages of this method? let's see. So it minimizes the surface agglomeration. How? Since we are using a non-aqueous solvent, what, like usually the solvents that are used is ethylene glycol or polyethylene glycol. So what is the advantage of using ethylene glycol? So the thing is, when we use ethylene glycol, there's a layer of glycol, sorry. There's a layer of glycol formed around the nanoparticles. What that layer will do is prevent those nanoparticles to agglomerate. So one of the disadvantages was of that method that the nanoparticles were agglomerating. But in this, since there is a layer of glycol layer, so there is no agglomeration of the nanoparticles. Second advantage is it minimizes surface oxidation. Obviously, we don't need to maintain inert conditions in this method. Why? Because there is a glycol layer present around the nanoparticles. Since there is a glycol layer present around the nanoparticles, there is no chance of uh, oxidation of the nanoparticles. So we don't need to use inert atmosphere for this method. It can be used at very high temperatures. Why? Because in the previous method we were using aqueous solution and water evaporates at 100 degrees Celsius. But it is not the case with ethylene glycol or polyethylene glycol. We can use ethylene glycol or polyethylene glycol at very high temperatures also, like 160 degrees Celsius, 180 degrees Celsius. So this is another advantage. And one more advantage is it prevents the hydrolysis of fine nanoparticles. How? Because we are not using any aqueous solution in this particular method, so there is no chance of getting hydrolyzed. So these were the advantages, and there are not as many disadvantages of polyol method, so we won't be discussing that. So this brings us to the end of these topics. I hope you understood everything.